Okay, 1.6 factoring polynomials using quadratic methods. Objective students will be able to factor polynomials using quadratic methods. So here's what we're talking about. We look at this guy, and it kind of just looks real scary. But really, this is the same thing we were doing in the last lesson. The first thing I'm going to do is I'm going to see if there's any number I can take out of every single term. And there is, because 6 goes into all of these. So I'm going to write 6 over here. Next, is there a variable that I could take out of every single term? And yeah, I see there's at least a k to the first power in each one, so I can write that here. Now, I can write what's left. Well, 6k cubed, if I was to take out a 6, would just leave me with 1, and k cubed to take out a k is going to leave me with k squared. 24 divided by 6 is, or negative 24 divided by 6 is negative 4, and k squared, take out a k is just going to leave you with a k. And then 18 divided by 6 is 3, and then there's no k left because we took it out. So now we factor this down to a much simpler trinomial here, and you'll notice that this is actually a quadratic now. So leaving the 6k out here, we're going to go ahead and just factor this guy. So I need something that multiplies up to 3 and adds up to negative 4. We could do the x if we want, 3, negative 4. Two things that multiply up to 3 is 1 and 3. But we need it to add up to negative 4, so how about negative 1 and negative 3? Still multiply up to positive 3. So we could write this as k minus 1 and k minus 3. And now we've factored this thing completely. So see if there's something you could take out of the whole thing first, and then you could factor like normal. Alright, let's try this guy. See if there's anything you could take out first, and then factor like normal. You may want to pause the video, and I'll put the answer up in just a second. Okay, so first I saw that I could take a 9x cubed out of every single term because a 9 goes into all these numbers and x cubed goes into all these variables. It's the lowest degree that we have is x cubed. So when I take a 9x cubed, what I have left is x squared minus 7x plus 12. I did my little x factor trick or star method and got x minus 3 and x minus 4. So that's it. It's all the way factored down. Let's try another one. It says, what if there is no GCF, stands for greatest common factor, to pull out first? Well, there's a very helpful tool called U substitution. So over here I just wrote this down. When using U substitution, first try the variable expression in, and this should say the middle. I guess it got cut off. So what do I mean by that? The variable expression in the middle. Well, I'm talking about this, that n squared. See, right now this is a little tricky to factor, but if I was to take this n squared, and I can write this over here, I can just say let, and this is what we mean by U substitution, let U equal n squared. And then we can quickly find out, well, what does U squared equal? So if I was to square U, I'd get U squared on the left, and then I would get n squared squared, which is n to the fourth. The reason why I'm doing this is, you can see very quickly, I can substitute in for an n squared now, a u, and I could substitute in for an n to the fourth, a u squared. So let's rewrite this. When I rewrite this, I get u squared minus 5u minus 6. Now, this problem is real easy. It's real simple. This is just a real generic factoring. So we can do our x factor thing, our star method. We need something that multiplies up to negative 6, adds up to negative 5. How about 6 and 1? And how about negative 6 and positive 1? So I can make this u minus 6 and u plus 1. Now the only thing with u substitution is my answer didn't start off with u, so I need to get back to him. So, well, what did u really equal? Well, u is just n squared, so my last step is just to rewrite it. N squared minus 6, n squared plus 1. And there we have it. We factored this nasty trinomial. So I want you to try this one again. I'm going to help you get started. Remember, you're looking for that middle term. This middle term is x cubed. So we're going to say let u equal x cubed. And then let's go ahead and square both sides, too. That means that u squared equals x cubed squared would be x to the 6. And now you can just easily plug these guys in and rewrite it. So this should look like u squared minus 9u plus 8. Now you should be able to factor it pretty good from here. Go ahead and pause the video and finish this one, and then come back when you're ready. Okay, so I went ahead and factored it, got -1 and -8. Then I remembered that my answer didn't start off with u, so I need to go back to x's. So I just plug in what I know that x is, which is x cubed, so this is really my factor. And for this type of problem, we can actually keep going. There's something called cubic factors, but it's not something we're going to get into here. But there is actually more that we could factor here, but that's for another day. Okay, let's go on to the next thing. It says, what if there is more than one variable? So here's the deal. If there's more than one variable, there's a couple things you can do. First of all, you could just kind of cancel the last variable or just kind of ignore it for now and then put it back in later. But I don't really like that too much because it's not really math friendly. You don't really know why you're doing that. So this is where that skill called grouping really comes in, where we're going to spread this out. We're going to write the first term and the last term. And really there's like a little imaginary 1 right there. And so we need two numbers that multiply up to -30 but add up to -1. So I'm thinking 6 times 5 is 30, so maybe a -6 and +5. So I'm going to go ahead and write that -6xy plus 1xy. And now essentially what we have here is the same thing, because -6, oh I'm sorry, that's a typo. That should be a 5 there. Because -6 plus 5 still makes -1, so this is the same thing. I've just kind of expanded out this expression. And now we're going to look for the greatest common factor here. Well, that would be an x. So I take out an x and leaves me with x minus 6y. And the greatest common factor here would be a 5 and a y. So let's go ahead and take out a 5 and a y. That will leave me with x. 30, or -30 divided by 5 is going to be -6. And y squared divided by y is y. Again, this is what we've done this before, but since these two match, we could do reverse distribution property, and we could say, hey, x minus 6y goes over here, and these two make its own binomial of x plus 5y. And now we've factored this thing with two terms. Now, what I was saying earlier that you could have done is you could have done the same thing we've been doing all along. You could just kind of do the star method, and you got a -30, and you got a -1, and then you get -6 and 5. And so you could rewrite this as x minus 6, x plus 5. But the thing is, you'd have to know, since there was a y here, you got to go and just put the y's back in. So that's the other way you can do it. I just don't like that as much because you don't really know why you're doing it. But we got the same thing. So whatever works best for you, just make sure that you don't leave out these y's because that's really a part of your factor. I'd rather see you guys group these ones. So on the next one, we got practice number 3. I want you guys to try this one as well. I'm going to give you some time, so pause the video and then come back when you're ready. Okay, so I spread them out, wrote these two things first, and then I was looking for two numbers that multiply up to -8 but still add up to 2. I got +4 and -2, so I just spread those two terms out. I spread 2 into a +4 and -2. Then I looked for the greatest common factor of the first two, and I got an m, which left me with m plus 4n. And then I looked for the greatest common factor of the last two, and I got -2n, which also left me with m plus 4n, which means that this factors nicely. So these two I could just write over here, reverse distribution property. Combine these as one binomial. There's my factor. All right, that's it for 1.6. See you guys on the next video.